All right, in this video here, we're going to talk about factoring a trinomial using what we call the AC method. All right, so this is for trinomials that are in the form ax squared plus bx plus c. And the AC method refers to that leading coefficient, that number that's in front of the x squared, and that constant at the end, the number that doesn't have the x attached to it. Right? Those are the a and the c that we're talking about in this method. And this is true when a is not equal to 1. Now, you can still use this method when a does equal 1. But when a is equal to 1 and it's just an x squared out front, there's an easier method to use, and I did another video of that just called factoring a trinomial. So you might want to check out that video of when it's a 1x squared, although this AC method also works when it's a 1x squared. It's just kind of overkill. There's a simpler way to do it when there's a 1x squared here, right? But for this one, for this AC method, we're talking about trinomials that look like this one, 4x squared plus 20x plus 9. Right, so that number in front of the x squared is not just a 1, and so I have to use this AC method to factor it. So what the AC method says is the first thing you do is multiply a times c. That's why they call it the AC method, because that's your first step. Right, so my a in this case is the 4, my c is the 9. So I multiply 4 times 9, and that gives me a 36. Right, so now, and if you watch the video that I did on the factoring a trinomial when it's a 1x squared, what we do now is similar to what we did there. Right, now I'm going to look for two numbers that multiply to equal a 36 and add up to equal that number in the middle, which is a 20. Right, when it was a 1x squared, we just looked for two numbers that multiply to the 9 and add up to the 20. But when there's another number in front of that x squared, we have to kind of factor that into it. Right, so 4 times 9 gives us our multiplier number, 36. So we need two numbers that multiply to that, but still add up to that 20, that b that's in the middle. All right, so that's kind of the key thing of what to do or how to get started with this AC method. All right, so I need two numbers that multiply to 36 and add up to 20. And again, if you see them, just go ahead and write them down. If you don't see them, start making a list. Right, 36 can be 1 times 36. Those are not going to add up to 20. It can be 2 times 18. And there we have it, right? 2 plus 18 will give us 20. So those are the numbers that I need. All right, if you watch the other video that I did, sometimes you have to make a little bit of a longer list, and what I usually do is just go in order. 1 times 36, 2 times 18, 3 times 12, 4 times 9, 5 doesn't work, 6 times 6. Just kind of do the numbers in order so you don't miss any, and then find the one out of those that actually adds up to the 20. And once you find the one you need, you can just stop. Right? You don't have to make the whole list. 2 plus 18 gives me 20. I have the numbers I need. All right, now, this is where now this, again, is different from the easier type of trinomial when it's a 1x squared. We don't just put the 2 and the 18 into our parentheses and then that's our factors and we're done, right? There's more to it with this AC method. What I do with that 2 and that 18 is I use that to split apart this middle term, right? So what I do here is I copy down the 4x squared, right? That 20x, I break that up into plus 2x plus 18x. And then I copy down that plus 9 just like it is. Right, so I multiply a times c, I get my multiplier number, I find two numbers that multiply that, add up to the one that's in the middle, the 20. I get those two numbers, I use those to split apart that 20x. All right, the plus 2x and the plus 18x. All right, and what we have now, you might say, well, that actually made things more complicated because I had 3 terms before and now I've got 4 terms, so this is getting more complicated. But there is a method we can use when we have 4 terms, and I made a video about this method. So if you haven't seen this yet, you might want to pause this here and check out that other video. It's called the factor by grouping method, where I explain how to factor something that has 4 terms like this. So again, if you haven't seen that yet, you might want to check out that video before we proceed with this one, because we need to use now that factor by grouping method to finish off this factoring. Right? And the factor by grouping, what that says is, when I have 4 terms, or 6 or 8, or some even number of terms, I split them into groups. So I take my first 2 terms and my second 2 terms. Right? And then for each group, I factor out the greatest common factor that each group has. Right? So for the 4x squared plus 2x, the 4 and the 2 have a 2 in common, right? And the x squared and the x have an x in common. Right? So my common factor for that first group is the 2x. And if I factor out a 2x, what I'm going to be left with is a 2x and a plus 1. Right, now, a lot of people make the mistake of saying, well, I get that from the 4x squared, if I take out a 2x, 2 times 2 is 4, x times x is x squared, so that makes sense. But here I have the 2x already, so when I take that 2x out, there's nothing left behind, right? There is still something left behind. Remember, we're not just like subtracting away that 2x. It's more like we're dividing away that 2x, right? So when I do 2x divided by 2x, that leaves me with 1, right? Or another way to think about it is, remember, this greatest common factor thing is like doing the distributive property backwards. If I distribute this 2x back into the parentheses, 2x times 2x will give me 4x squared. I need to have this plus 1 here so that when I do 2x times 1, it gives me a 2x. Right? If I don't put that 1 there, there's nothing to multiply this by to give me that 2x that was there when we started. Right? So it's really important when your common factor is the exact term that you have, it doesn't mean there's nothing left behind. You still have to put that 1 there, almost like a placeholder, so that when I distribute the 2x back in, I have a 1 to multiply it by to give me the 2x. All right? A really important little thing that sometimes people make a mistake on. All right, so that's our first group, the 4x squared plus 2x. I factor out the common factor of 2x. My next group is the 18x plus 9. All right, so what do those two have in common? Well, 18 and 9 can both be divided by 9. All right, so I pull out the common factor of 9, which will leave me with a 2x, and then once again, a plus 1. Right? Even though I pulled out the 9, I still need that 1 there so that when I distribute this back in, 9 times 1 gives me 9. Right? And the 9 times the 2x gives me the 18x that I had here. All right, and remember, when you're doing this factor by grouping method, these two parentheses here have to be exactly the same. If they're not, either you made a mistake or you can't factor what you've got. Remember, if one of these has like a, if the signs are backwards, just pull out a negative on one of them and then that'll make the signs match up, right? But if this one's like a 2x plus 1 and this one's a 5x minus 7, you either completely screwed something up before or you're just not able to factor that expression. So you need to double check that. But once we do that, the common factor of each group, and these two match up, they're both 2x plus 1. Remember, the 2x plus 1 gives us one of our final factors, and the stuff that we pulled out, the 2x and the plus 9, gives us our other factor. And just barely enough room to write that over there. So that's our final factoring of the 4x squared plus 20x plus 9. Right, when we factor all that, we get 2x plus 1 times 2x plus 9. And just like with any other type of factoring, if you want to double check it, just multiply it back together. Right? If I FOIL this, the 2x times the 2x gives me the 4x squared. That part's good. Right? 2x times 9 gives me the 18x. The 1 times the 2x gives me 2x. And when I add the 18x plus the 2x, just like how I split it apart here, that gives me the 20x. And then the 1 times 9 at the end gives me that plus 9, and so it checks out, and I know I have the correct answer here. All right, so that's factoring using what we call the AC method. Right now, when you are factoring a trinomial that has a number other than 1 in front of the x squared, you don't always have to use this AC method. Depending on how good you are with numbers and how well you can juggle numbers in your head and do that mental math, some people can just look at this and say, well, I know I have to have two parentheses. To get a 4x squared, let me try a 2x and a 2x, and to multiply to 9, I need a 3 and a 3 or a 1 and a 9, and then you just kind of mentally do the foiling stuff and figure out, oh, if I put a 2x plus 1 and 2x plus 9, that's going to equal this. If you're able to do that, then you can do that and you factor it, right? But if you don't have that ability to do that mental juggling of all those numbers and variables and stuff, this AC method is the way you can work your way through factoring one of these where that leading coefficient, that a, is not 1. All right, so that's our first example. We have another one here that we'll take a look at. We got 3x squared minus 11x minus 20. And I'm actually going to erase a little bit of what's up above here just so we have enough room to see what's there. All right, so 3x squared minus 11x minus 20. So again, first thing I notice, I have a trinomial, which means I can't use the factor by grouping method. Remember, that only works when I have like 4 or 6 or like an even number of terms. So, and it's not a 1x squared, so I can't do like that easier type of factoring a trinomial. So if I'm going to be able to factor this, I'm probably going to have to use the AC method. Right, so first thing I do is multiply the 3 times the negative 20, which is negative 60. Right, and that negative there is important. Right, the C is not just 20, it's negative 20. So I multiply 3 times negative 20 and I get negative 60. So I need two numbers that are going to multiply to equal negative 60 and add up to equal that negative 11, that B that's in the middle. All right, so now I got to figure out what those numbers are going to be. Well, the factors of 60 are 1 times 60, 2 times 30, 3 times 20, 4 times 15, and I think that's going to be the one. Remember, this has to be a negative 60, which means one of these two numbers is going to have to be negative And to make them add up to a negative 11, if I make it 4 times negative 15, right, that will multiply to negative 60, and the 4 plus negative 15 adds up to negative 11. All right, so again, if you don't see the numbers right away, just start making a list, 1, 2, 3, 4, 5, 6, 7, go on down until you find the one that adds up the way you need it to. All right, just keep in mind, when this is a negative, one of those has to be negative, so that kind of gets thrown into it. All right, so the 4 and the negative 15. I use those to split apart that negative 11x that's in the middle. So I have 3x squared plus 4x minus 15x minus 20. Right, and another note here, when you're doing this part where you split it apart, the order that you put these doesn't matter. Like if you wrote this as 3x squared minus 15x plus 4x minus 20, that's going to be okay. Your next couple steps will look a little bit different from mine, and your final answer, the factors might be switched around. But remember, if the factors are switched around, it's still correct. Right, so it doesn't matter the order that you put these. Like up here, if I had put plus 18x and then plus 2x, my next steps would have been different, but the final result would have been exactly the same. So don't worry about which one to put where, just put them in there. All right, so I got my 4 terms now, which tells me I need to do my factoring by grouping. All right, so I group my 4 terms into groups of 2. The first one's 3x squared plus 4x. Well, the only thing those two have in common is an x. So I can pull out an x, which leaves me with a 3x plus 4. And the negative 15x minus 20, well, the 15 and the 20 both have a factor of 5. Since they're both negative, and since I see here that my parentheses here has 2 positives in it, I'm going to factor out a negative 5 instead of just a 5, right? And that's going to leave me with a 3x and a plus 4. Right? 'Cause remember, these 2 parentheses have to be exactly the same, and so in order for them to be exactly the same, I have to pull out that negative 5 to make the stuff that's in here positive. Right, so again, that factor by grouping method, you have to make sure these 2 parentheses match exactly. Sometimes you have to pull out a negative in order to make that happen, which we had to do here. All right, so since those 2 parentheses match, they make up one of my factors, which is 3x plus 4. The other factor is the stuff that we pulled out, the x and the minus 5. All right, and there's our factoring of 3x squared minus 11x minus 20. Right, sometimes people try to do these types of problems by what we call the guess and check method, like set up 2 parentheses and just kind of start plugging numbers in. Well, what multiplies to 3? That's 3x and x. What multiplies to 20? Let me try a 1 and a 20 or a 20 and a 1. Let me try a 2 and a 10 and a 4 and a 5. Right? That method is okay. It'll work if you have the time to do it. And sometimes it takes longer. Like sometimes if you guess the right one on the first guess, then that's pretty quick to do. Sometimes, you might have to try 6 or 7 or 8 different things before you actually find the one that works. So that's why that guess and check method sometimes is not that great. Whereas this AC method, it pretty much takes the same amount of time every time you do it. Right? There are some steps to it. It takes a little bit of time to get through, but it's always the same steps, right? So it's always multiply the A times the C, find 2 numbers that multiply that and add up to the B in the middle. When you get those 2 numbers, split apart that middle term, do the factoring by grouping, and then you get your factors from there. Right? So that's what we call the AC method. Very important for when you have a coefficient in front of the x squared that isn't a 1. Remember, like I said at the beginning of this video, if there is a 1x squared there, you can still use this AC method. It just takes something that could be quick and makes it this longer method. So it's not always appropriate to do that, but it will work if you use that. All right, so that's our AC method for factoring.